and equations. So this is what this whole chapter is about, the radical expressions and equations. We did 10-1. 10-1 was our Pythagorean theorem stuff. 10-2 we skipped over because it was just breaking down the roots, which we did before. This is one of those things that this chapter is kind of chopped up because I do some of this stuff earlier on in the class. Okay, we did the square roots, and I like to put the simplifying the square roots in the square roots and exponents chapter. Um, some of the stuff we're going to do today, we're going to do the FOILing, the distribution. We're just going to do some of those to just kind of remind ourselves. We're going to add one thing on there. It's called, oh crap, I forget what the name of it is. We'll get to it. All right, but today it's just operation with radical expressions. This is 10-3. So this is where we're at. Like I said, a lot of this is going to feel like review for us. There'll be one new thing here at the end. All right, so operation with radical expressions. The first thing, combining like radicals. If you're going to combine like radicals, you can combine radicals only if the roots are the same. They must be exactly the same. If that's the case, then you just want to add the coefficients out front. You do not add anything inside the root together. All right, it's just kind of like adding 2x and 3x. 2x and 3x is 5x. It's not 5x squared or 5x2 or something like that. All right, the x's just tag along. It's the same way with the roots here. So I have that example on the board. 6 root 11 plus 9 root 11. Is that root exactly the same? Yeah, it is. So you add the coefficients. What's it going to be when you add those together? How about 15? 15 root 11. Add 6 and 9 together, you get 15, and then the root 11 just tags along. Simple enough, right? All right. We good if I move on? No? All right, but as long as your root's the same, you can add the coefficient out front. Now, sometimes you have to simplify first. Sometimes you won't have roots the same, but you might have like a root 4 and a root 8. Well, then you can simplify them, and maybe you get 2 root 4s or something like that, or 2 root 2s, and then you can add those two together. Now we good? All right, so here's 5 problems up here on the screen. If you look at them, the first 3 already have the roots simplified. Root 3, root 2, root 5. The second ones, these ones need to be simplified first. Okay? So I'm going to give you about, I don't know, 3 or 4 minutes here. I want you to simplify these ones here, just add them or subtract them. Down here, you'd have to simplify first. You can break down to 12 and simplify it. If you get a root 3, then you can add it together. Over here, you have a root 28. Break it down. So if you get a root 7, you can add them together. If you don't get them the same thing, then you can't add them together. All right, so I'm going to give you a few minutes to try those ones there. Okay, number 1, Sarah, what'd you get? -4√3 is correct. All right, this will be a 1 out front. 1 minus 5 is -4. It's the same roots. We're good. Carter, number 2, what'd you get? -1√2. That works. Could you also have -√2? Yeah. Yep. Either one would be the same. All right, Espy, what'd you get for number 3? 7√5. Okay. Russell, number 4, what do you have to do first? What's it break down to? Yep. So then now you have 5√3 minus what? 2√3. Can I combine them now? Yes. So what do you get? 3√3. Okay. Maurer. Yeah, you. What do you do on this one first? What's it break down to? A 2, 2, and a 7. Okay, so now I have 4√7 plus 4√7. Okay, so we bring the 2 out and multiply by the 2 that's already out there. Add those together, what do you get? 8√7. Not too bad, right? Any questions on adding them together? Okay, next one. Multiplying radical expressions. Okay? Anytime you're multiplying radical expressions, multiply the outside, multiply the inside. I have 2 up here on the screen. One is distribution. One is foiling. Okay? Remember, multiply the outsides, multiply the insides. So, when I start this first one, I have root 10. I distribute it through to a root 6 and a 3. Okay, so root 10 and root 6, I just have insides, correct? So I multiply the insides, I have, what's 10 times 6? Root 60. Multiply root 10 times 3, I have what? 3 root 10. All right, now I need to break stuff down if possible, right? Simplify from there. So the 10, that's just a 2 and a 5, so there's nothing there. Now a 60, that's going to be 2, 2, 3, 5. 2, 2, 3, 5. Is there anything I can bring out there? Okay, I got a 2, and that's going to leave me with a root 15. And then over here, I just have 3 root 10. Are those guys the same root? No, so I can't combine them, can I? I'm stuck right there. Done. Next one, FOIL. FOIL first, outside, inside, last. Okay, so root 6 times root 6 is root 36. Root 6 times root 3, root 18. Negative 2 root 3 times root 6. Yep. Negative 2 root 3 times root 3 is negative 2 root 9. All right, go back through here. What's the square root of 36? That'd be 6 and 6. It'd be 2 2s and 2 3s, or 6 and 6. That's just 6. 18. Does that break down? It's a 2, 3, 3, right? I like to break them down first, personally. I like to get them as simple as possible and then add if possible. All right, so this one here, we have 3 root 2. Next one, another 18, 2, 3, 3. Okay, so I bring a 3 out. I have negative 6 root 2. And then last one, a 9, that's what? 3 and 3. So I bring a 3 out. I have negative 6. Now combine like terms, here and here, here and here, right? What's 6 minus 6? 0. 3 root 2 minus 6 root 2 is? I have 3 root 2. There you go. Any questions on those? You guys remember doing this stuff? This is just straight review right now. All right. Here is one distribution, 2 foils. I'll give you about 5 minutes to try those. were. So these three. First one, we distribute. We multiply the insides, multiply the outsides. In this case, we get root 12 plus 5 root 2, right? Root 12, we can bring a 2 out, so we got 2 root 3 plus 5 root 2. Can we combine those? Nope, there's nothing we can do there. Second one, all right, we have to be careful. When you FOIL this guy, you have to do your root 11 times root 11 is root 121. Okay, root 11 times negative 3 is negative 3 root 11. Negative 2 times root 11 is negative 2 root 11. Negative 2 times negative 6 is positive 6, right? So then from there, this becomes 11. This one and this one are like terms, aren't they? And then this guy's a 6. So I have 6 plus 11, which is 17. Negative 3 and negative 2 is negative 5. So we have negative 5 root 11. How many people got that one? All right. Last one. Distribute the first one, distribute the second one. So the first one, we have 4 root 18. Okay, and then plus 3 root 36. Good so far. And then we have negative 2 times 4 is negative 8 root 9. And negative 6 root 18. Good on that? That's an 18, we're good. Okay. All right, so then 18 breaks down to what? 3, 3, and 2. Okay. So I can bring a 3 out here, making this 12 root 2. 36 is what? It's just 6. Okay, 2, 2, 3, 3. So 6 times 3 is 18. 9 is going to be 3 and 3. So what's 3 times 8? Negative 24. Last one, 18 again. That's a 2, 3, 3. Bring a 3 out. Negative 18 root 2. Okay, combine like terms. Here and here. Here and here. So I'm going to do my whole numbers first just because I like them better. So that's a negative 6. 12 and negative 18 is negative 6 root 2. How do we do? Is that the same answer? No. You just didn't combine the two roots. Okay? Okay. Yeah, if you would just, this would be a, that should be a 2. Yeah, that should be a 2. All right, who went through 3? All right, now, here's the new part for today. If you can do this, you can do this. All right, so rationalizing denominators. Here's a rule of math. Rule of math is you cannot leave a root on the bottom of a fraction. You just can't do it. All right, remember we couldn't have negative exponents? All right, that was the rule. There's no negative exponents. Same concept is here. We cannot have a root on the bottom of a fraction. All right, so 6 over root 3 or root 2 over root 5, that becomes an issue for us. We have to get that root out of the bottom. So the process of getting that out of the bottom is called rationalizing the denominator. We want to clear the denominator of any rational expressions. So the first one here, 6 over root 3. What you want to do to get rid of that is I can multiply the bottom by root 3. Now, if I do it to the bottom, I have to do it to the top as well. So you multiply by whatever the root is on the bottom. Okay? Do it at the bottom, do it at the top. Same thing with an equation. If it's an equation, you multiply both sides by it, right? Other way you can look at this is finding the common denominator. If I had 1/2 and I needed to make it over 4, I'd multiply the bottom by 2. I have to do it to the top as well. Remember doing that? So now I multiplied the top and the bottom both by root 3 over root 3. Root 3 over root 3 is 1, so I'm still just multiplying by a factor of 1. So on top now I have 6 root 3 over root 9. Now what's root 9? 3. So I have 6 root 3 over 3. Can I simplify that any further? 6 and 3 simplify, don't they? Okay, so I have 2 root 3. All right. My answer would be 2 root 3. Second one, I have a root on top, a root on the bottom. Which one do I have to get rid of? Root on the bottom. What is the root on the bottom? Root 5. So what do I need to multiply by? Root 5 over root 5. Boom, boom. So on top I have what? Root 10. On the bottom I have root 25. Now, top is just 2 and 5, so that doesn't change anything. The bottom, 25 is 5. Anything else I can do? Nope, I'm done. Okay? Does that make sense what I just did there? Okay? Let's do one more here. What if I have this? Let's do 2 root 3 over 4 root 2. Okay? Actually, I don't want to do 4. Let's make it 5 on the bottom. Okay? So 2 root 3 over 5 root 2. Now, again, it's not multiplied by what's on the bottom, it's multiplied by the root on the bottom. So what's your root on the bottom here? Root 2. So I want to multiply by root 2 over root 2. Now, back to our rules of multiplication. Multiply the insides, multiply the outsides. So I have 2 root 6 over 5 root 4. Right? Okay, 2 root 6, does that simplify at all? No, it's just a 2 and a 3, isn't it? So there's nothing I can do there, so it's still just 2 root 6. On the bottom, though, a 4 is 2 and 2, so I pull a 2 out. 2 times 5 is 10. That gets me to here. Last thing, is there anything else to simplify? 2 there, so I have root 6 over 5. All right with that? So whatever the root is on the bottom, multiply the top and the bottom both by that root. Here's 4 of them. Give it a shot. Now, first one, what do I need to multiply by? Root 2 over root 2, right? On top, I have what? 6 root 2. On the bottom, I get root 4. Root 4 becomes what? It becomes 2. Then I can simplify out front, and I'm left with 3 root 2. Second one, what do I need to multiply by? Root 6 over root 6. Okay, so on top I have 5 root 6. On the bottom I have root 36. Root 36 becomes 6. And I have 5 root 6 over 6. Is there anything I can do there? Okay, I cannot. Next one, number 3, what do I need to multiply by? Root 3 over root 3. So on top I have 6 root 3. On the bottom I have 2 root 9. Root 9 becomes a 3. So 3 times 2 is 6. So I have 6 root 3 over 6, which is just root 3. Last one, what do I need to multiply by? Root 2 over root 2. So on top, I'm going to have 2 root 6. On the bottom, I have 4 root 4. Root 4 becomes 2. So I have 2 root 6 over 8. Simplify. I have root 6 over 4. Who went 4? Who went 4 for 4 there? Good. Last thing of the day. It pairs right with this. What happens if I have more than just one term on the bottom of my fraction? What happens if I have something like this, 10 over root 3 plus 2? Then we have to use something called the conjugates. The conjugates are essentially the same expression with a different sign. Okay, same expression with a different sign. You'll see that here in a second. And this is how I simplify and get the square root out of the bottom of a fraction if there's multiple terms in the fraction. All right, so in this one here, I have root 3 plus 2 on the bottom. That's 2 terms. I can't just multiply by root 3 over root 3. If I multiply by root 3 over root 3, the root 3 goes away, but then I get a 2 root 3. Then I'd have to do it twice, essentially. All right, and we don't want to do extra work, so we have to multiply by something called the conjugate, right, SB? Okay, what's the answer? 20 minus 10 root 3. All right, we'll write it up here and see if that's what we get.
20 minus.
That?
No. 10 root 3 over.
There's no more fraction.
No more fraction.
That's wrong. He's already.
Okay. Well, let's see. All right, so our conjugate here is going to be the same thing, switch the sign. So if I told you that I had x plus 6, what's the conjugate of x plus 6? X minus 6. That's the only thing you do to find a conjugate, okay? You just switch the sign that's in between the two. So on this one, I want to multiply by the conjugate of the bottom. We have root 3 plus 2, so our conjugate is going to be root 3 minus 2. Do it to the top, do it to the bottom. Okay? So then on top, I multiply the 10. This turns into distribution on top, FOILing on the bottom, right? So on top, 10 times root 3 is 10 root 3. 10 times negative 2, negative 20. On the bottom, I have to FOIL. So root 3 and root 3 is root 9. Root 3 and negative 2 is negative 2 root 3. 2 and root 3 is 2 root 3. 2 and negative 2 is negative 4. All right, now simplify the top, simplify the bottom. On top, doesn't look like there's anything I simplify, is there? So I have 10 root 3 minus 20. On the bottom, this guy becomes a 3. All right, so I have a 3 and negative 4, which is negative 1. This and this are like terms, but they go away, don't they? Because I have a minus 2 and a positive 2. That becomes 0. So then I have negative here. All right, I can leave it all like this, or I can just make it negative 10 root 3 plus 20. Just distribute that negative on the bottom to both things on top. Okay? So how'd you get that one, SB?
Just for
Power of a calculator.
Power of a calculator.
photo math.
Photo math.
Calculator.
Photo math.
Calculator.
All right.
Come here, I'll do it.
Questions? Questions on this, guys? Easy? Okay. Here's 3. You try them. Yes, whoever you If we want to multiply this by the conjugate, the first one, we have to multiply here and here. What's 6 times root 2? 6 root 2. 6 times 3 is 18. Now on the bottom, it's 2 terms and 2 terms, so we have to FOIL. All right, root 2 times root 2 is root 4. Root 2 times 3 is 3 root 2. Negative 3 times root 2 is negative 3 root 2. And then I think everyone I saw missed this. Negative 3 times 3 is negative 9. Now you go back through and simplify. The whole concept of multiplying by a conjugate allows you to do this. Every time you will be able to do that. If you do it by the conjugate correctly, you're going to have to multiply, or you'll have to add a positive and a negative the same, and it cancels out. So then on top, I have 6 root 2 plus 18. Now, square root of 4 is what? 2. 2 minus 9 is negative 7. Done. Second one, what's the conjugate of root 7 minus root 2? Root 7 plus root 2. Do it at the top, do it to the bottom. Okay? So on top, I have 10 root 7 plus 10 root 2. On the bottom, I have to FOIL. So I have root 7 times root 7 is root 49. Root 7 times root 2 is plus root 14. Then I have here and here. So I have negative root 14, and I have negative root 4. All I did was FOIL. That's not the answer. This is gone. This is gone. What's square root of 49? 7. Square root of 2. Or square root of 4. 2. And that's a negative. So on top, I have 10 root 7 plus 10 root 2. On the bottom, I have 7 minus 2, which is 5. You could go here and here. That'd be 2 root 7 plus 2 root 2. Okay, last one. Multiply by the conjugate. Conjugate's going to be root 10 minus root 5. Root 10 minus root 5. On top, I have negative 3 root 10 plus 3 root 5 over. On the bottom, I have root 100 minus root 50 plus root 50 minus root 25. Root 50s are gone. What's square root of 100? Square root of 25? Negative 5. So on top, I have negative 3 root 10 plus 3 root 5. On the bottom, I have 10 minus 5, which is 5. Answers. 1, 2, 3. Anybody go 3 for 3? Yes, Sarah.
How can this be applied anywhere? Honestly.
Any other questions?
Like, exactly.
I'm honestly
Dick.
curious. I don't know how this can be applied.
Any other questions on how we do this?
I have none.